The plates go through more than a dozen processes including laser cutting, bending, riveting, welding, grinding, oil and rust removal, spraying, etc., before arriving at our final chassis assembly process. First of all, the screws, nuts, bolts, door locks, hinges we see on the outside of the chassis are all made of stainless steel, which has better anti-corrosion effect and longer life. Open the inside of the chassis, and the door panel is lined with high-density flame-retardant sound-absorbing cotton. It is made of polyester fiber with a layer of flame-retardant leather. The sound-absorbing effect is better, high-end, atmospheric, and has a long service life. All around the machine head use this flame-retardant sound insulation cotton. The bright white interior is our bell mouth and vent valve. In the past, the bell mouth was made of carbon steel coils and then welded. This process has thin materials and the risk of false welding, slag. RAETTS uses an aluminum alloy one-piece casting process to ensure that the thinnest part is 6-8 mm, the surface is smoother, and the wind resistance is smaller. When the wind passes through at high speed, the noise and heat generation are relatively smaller due to the smooth surface and small wind resistance. The left and right sides of the chassis adopt a U-shaped bending structure. This structure cleverly allows a good exchange between the air inside the chassis and the filter element. Then the chassis uses the back and forth reflection principle of this U-shaped structure to keep the sound from being transmitted outside and can achieve good ventilation effect. The final outlet uses standard high temperature resistant rubber soft connections. The rubber soft connections have been verified in the blower industry for 10 years. The technology is mature and has a long life and safety and reliability. The next video will take you through the internal assembly and testing process of the maglev turbo blowers and air bearing blowers.